Hello, I am Charles, and I am a senior engineer at Thickmill. And as Jess just said, I've spent the majority of the last 3 years working on Atlaskit with the Atlassian team. And I've also spent some time helping with the V2 and the V3 refactor of React-Select. So for that, I apologize. Um, cool. So I guess I'm just here to share some learnings about design systems in React, and I guess how to build them. So before that, though, I guess it's important for us to cover what a design system is for those of us who are uninitiated, and also to cover what the core value of a design system is. Now, there are a lot better explanations and definitions out there, so definitely don't take my word for it. But for the purposes of this talk, I'd like to propose a design system as a system of design guidelines and artifacts that allows an organization to consolidate two main things: design decisions, obviously, and also non-differentiating work. What I mean by that is, well, by locking down and sharing critical design decisions, a design system enables engineers and designers alike to not have to waste time on kind of trivial decisions like, what font to use or what color to use in a particular interaction state. And instead, that time can be spent on more interesting and more challenging questions to do with their individual product or usage context. Similarly, it turns out there's a lot of common work when we build out user interfaces. So we kind of do the same thing when we build a button or a modal or a select over and over again. And so when a design system lets us consolidate that, engineers can actually spend that time, save that time, and spend it on, again, building out more interesting solutions to their problems. So I guess to simplify it, design systems save us time, and that's their value. They let organizations save time on building applications. However, more often than not, consolidating design decisions and consolidating non-differentiating work can be diametrically opposed concepts. Sorry, I'm a bit of a weeb. When we aim to share non-differentiating work, we actually start with the most genericizable tasks, usually. And we aim to make our code as flexible and as reusable as possible. But this isn't always a good thing. In fact, when Atlassian, before Atlaskit, they were leveraging jQuery plugins and CSS style sheets to power their design system. And the implementation was solid and extraordinarily flexible because they're all super smart. But constraints were actually really easy to ignore. And as the organization scaled, the amount of fragmented product UI kind of just multiplied. And so did the Jira tickets and bugs. But on the other hand, too much constraint is also a bad thing. So early on in the life cycle of Atlaskit, I guess, Atlaskit aimed to learn from the drawbacks of this earlier jQuery implementation. So we locked down component APIs, and we let users do a lot less with our components than they could have previously. The intention here was that locking down the API would make it easier for the design system team to enforce good design choices and user experience. But this was not altogether true, and kind of resulted in two unfortunate outcomes. The first one is low adoption. Turns out if you make people jump through hoops to build a thing, they will not use your thing to build their thing. Or they'll build it themselves, which in design system land is kind of not the best. And the other thing is we found was hacks, right? Oftentimes, and we still kind of find it now sometimes, we would find products using our components in very creative but unintended ways, just to make their feature work. And I mean, to make their feature work, because it's important. But sometimes it would involve reaching into components. And other times, it might even involve ignoring React completely and leveraging DOM API and CSS overrides to make their thing work. This not only results in kind of buggy and brittle product UI, but it also made the design system unreliable. The reason behind this is now, from a design system maintainer point of view, I have no idea whether or not my patch release will be a major breaking change for products, and that's a real concern. And we're kind of back where we started before: more Jira tickets, more bugs, and again, time that hasn't been saved for products or for ourselves. And damn, this is kind of not a good place to be in, right? Like, if our design system is too flexible, we have fragmented user and brand experiences. But if our design system is too constrained, we force our users to either constantly rebuild logic or use our system in unintended and kind of dangerous ways. This seems like a lose-lose situation. This is also compounded by the fact that just by the nature of being a platform team or a design system team, we're usually outnumbered. So there ends up being, many more product teams and engineers using our products, using our components, than there are design system engineers working on them. So this is a relatively factual ratio of how many engineers in the design system team there are compared to the Atlassian consumers of that design system. So this is kind of where I wanted to start. The crux of this talk is, when faced with these seemingly insurmountable odds, what can we as a design system team do to make sure that our components are flexible enough for different products and features to use, but also constrained enough to reduce inconsistencies and design fragmentation, while also not kind of burying ourselves in work and also slowing down product development? Well, this is a React conference. My proposition is that leveraging composition patterns in React is probably the right way for us to toe this line. But what actually do users want to customize in our components or change in our components? Well, the usual things in a React component are, state, style, and DOM. We generally don't want to let users change state or mutate state in any meaningful way, so that's a no bueno. Styles, we definitely do want users to be able to affect change in, and users' products generally want to make changes here as well. But there's also a lot of really crucial design system decisions that we want to bake into our components that live on this level. So we need to reconcile these two things. DOM as well, similar. There's a lot of ways that a product consumer might want to change the DOM of our components. So for example, adding a tooltip into a button, or changing the anchor, changing a DOM element to be an anchor link instead of a button. But at the same time, similar to styles, there's a lot of design system decisions that we want to protect here, as well as accessibility like standards too. So again, we need some sort of way to reconcile this. Well, what can we do in our React Component API to solve this problem, or to let users basically change style and DOM concerns while also being constrained and guided by our design system? Well, let's not be too complicated. This is kind of the common theme for React components. We can use basic props, and we can use a theme to constrain a user within our system. By basic props, I mean primitive prop types that allow us to abstract style and DOM implementation from the user. For example, in this case, the user doesn't need to care about changing the background color of this button to blue, or changing the padding to 8 pixels. They just need to know that they need to set this appearance to primary in this particular context. And that's actually incredibly useful. The fact that we're able to abstract away implementation detail from the user while still letting them make choices about behavior or the look of a component within our design system constraints. But products constantly change, organizations constantly change, and new features are always getting added. So what happens when we need to add features initially not scoped by our design system? And what happens when these features are only specific to one or two use cases? Well, that's the first problem we have, which is prop soup. as component feature sets grow, maintainers need to be aware of all the different props, their values, as well as how they interoperate with each other. This makes getting full context on a component really hard. And of course, this slows down our ability to fix bugs, and this slows down our ability to ship features. On the product end, on the user's end, understanding which props they should use and what values are valid becomes way more difficult as more features get added in this way, even assuming our documentation is perfect, and it isn't. The second problem, of course, is a little bit more insidious. We end up forcing design system consumers to adopt performance and bundle size costs for features that they might not necessarily want if we're not careful. So for example, in this case, I have a button and I've added a new feature for adding a tooltip. So conditionally rendering a tooltip if this is set to true. But if not all products, or if not most products need this, then we're kind of forcing them to adopt a tooltip in their bundle for no real reason. And that's kind of bad. Well, what else can we do? Well, theming and design tokens also help us solve that first problem of prop soup. They let users make sweeping visual changes to a component or application through a more concise configuration. And this configuration is more, I guess, tightly tied to the implementation detail, which means that the design system maintainer doesn't have to add in a new feature every single time we want, a new background color or a new padding size. And that's kind of useful. On the other end of the spectrum as well, so long as the person leveraging the theme is using design tokens and we can guard for this, then they can apply a wide variety of really safely constrained stylistic changes without having to rewrite our implementation. But this doesn't really work out for customizations to the DOM. So again, adding a tooltip to my button. And this doesn't solve our second problem either, which we'll get to. This also falls apart for situations where my theme configuration doesn't support the kind of stylistic changes that a user might want. So maybe they want to change an animation duration, for example. Or in situations where they might want to apply a theme value in a very different way. So for example, taking a spacing token and applying it to a margin instead of a padding. Theming doesn't really let you do that. And that's, I think, the limitation of these two patterns. They're really good at letting you do things, letting you build features within the constraints of a design system. But as soon as a product or a user needs to build something outside those constraints, this doesn't really cut it, and this kind of falls apart. So what happens when a user has to do this? Well, with this current API, they can't, or they have to wait for the design system team to add in the feature. And that process is usually pretty slow because, again, a design system team has to account for the fact that this little change might have negative impact on a bunch of other components in other product use cases, and we have to do our due diligence and make sure that that isn't the case. So that usually means that, well, a product engineer, given this choice, will probably end up abandoning the design system, or at least in this particular case, and building it themselves, or building this feature themselves. But this is bad as well because our components would otherwise, do 80% of the work for them, and that's kind of a lot of code that they have to rewrite and reuse or redo. So what can we do to our components to make it easier for product engineers to build in exceptions, while also ensuring that they can use as much of the design system as possible, and also not forcing other users to adopt their performance, costs? Well, we can let it go, right? Or we can let it go. We can actually try and hand off certain implementation detail that we can give to the user. And React has a lot of patterns for us to do this, so we'll just breeze through them quickly. Exporting hooks, this is kind of the new fancy thing. It's all the rage. But hooks is a really nice way for us to seal off stateful logic and pass the outputs of that stateful logic to a user for them to, make DOM and styling implementation decisions. And that's kind of really powerful. So for example, in this case, we take the button that we were theming previously, and we can plug in the props given to us through the use collapse hook. And now we have a custom trigger for our collapsible component, which is pretty good. And also, if the user doesn't care about this and they don't want a custom trigger, we can just not do that as well. We can use that same hook internally to ship that state, and the user can use our default trigger. Higher order components also let us solve this problem, but they come with an obvious intermediary component, so that's a performance cost. But at the same time, they also let us seal off DOM and styling concerns that a hook might not necessarily let us do. But for the most part, these two patterns are kind of interchangeable in what they do. And lastly is render props. These are really good for letting us reach into, or letting a user reach into an interstitial node or a leaf node of a React component and make suitable DOM and styling implementations that way. So for example, here I'm letting a user change the underlying button element in my button to a reach router link without actually making any kind of changes to the underlying button wrapper or the icon around that button. Or I can just let the user make default style, minor adjustments to the style without actually overriding too many of the default styles. So that's kind of great, right? We have patterns for letting users build features with our components, with our constraints. And we have patterns for handing off implementation detail in situations where the constraints don't really apply. But we've only real examples where the customization only happens in one place, like the trigger of our collapsible, or simple components with few underlying DOM elements, like a button. But what about more complicated components? Components where a user might want to override multiple interconnected subcomponents with their own styles and state concerns, like a select or a middle dialog. Well, for these components, it's a lot harder to customize the DOM and styling in the ways we just described, because there are multiple subcomponents, and how these subcomponents are pieced together is actually implementation detail, and it's implementation detail that isn't really possible for the user to get right all the time, if at all. So this ends up kind of looking like this, right? We're forcing users to draw the rest of the fucking L. For these components, it's really important that we allow users to customize only the specific subcomponent they want to change. Otherwise, they may end up rebuilding functionality they didn't need to in the first place. And this isn't easy from a design system perspective, because different products might have use cases that warrant customizing different subcomponents. Like so. So we solved this in React-Select a while ago by leveraging a components prop. And this is a really nice way of solving this problem, because users can choose to target specific subcomponents in our tree and override them. And if they don't, they can just rely on our defaults. And if they only want to customize the styles, well, we can let them do that as well, and only that. This lets users opt into as much of our code and constraints as possible by only consuming what they need to. And I guess the work with products kind of validates this. Products are able to build, a user picker, a color picker, and a datetime picker by just leveraging this one component and using as much of that code as possible. But there is a trade-off to this pattern, and it's really important for us to be aware of it. And it's a trade-off that actually comes with any of the patterns where we hand off implementation responsibility. And that's that as we do so, we will inevitably expose private logic as part of our public API. And it's important to be mindful of this trade-off, because if we're not mindful of it, then we can end up, again, unintentionally shipping major breaking changes to our components. But still, this is kind of nice. We have React gives us the ability to let users build features within our constraints via basic props and theme. And we also have ways to hand off implementation detail to the user when those constraints aren't enough. For simpler components like a button or collapsible, we can leverage hooks, higher-order components, or render props. But more complicated components like a select or a modal, we can leverage a more targeted approach, like the components prop or base UI's overrides prop. But for a design system, it's important to remember that handing off implementation detail is ultimately an escape hatch for users. And regardless of how well encapsulated your code is, this is code that doesn't adhere to our constraints or design system's constraints. We leverage these patterns in order for us to reduce the surface area of these exceptions and also to make them more observable. But if we let them go unchecked, we can end up with the same UI fragmentation and reliability problems that we had before we actually applied these patterns. So it's really important to set up infrastructure and processes to document these cases, and over time, bring in those exceptions, where appropriate, into the core feature set of our components. In conclusion, design systems are hard, but by leveraging a combination of both high-level abstractions and ways to hand over implementation to the user through React patterns, we can hopefully build more balanced and more usable design system components. Thank you.